Okay, we just did the quiz with a 6-minute limit. Only 4 people in class today. This is very concerning. The scores were concerning. The scores were 10 points, 0 points, 0 points, 0 points. Okay. Now, that said, a lot of people did a lot of things right, but nothing was completely right. Okay, some people made the mistake of trying to line out everything so they could get them all done. Instead of starting on the first one, getting it, and going to the second one and the third one. That's an efficient way to do it if you're going to do it in 6 minutes. Okay, so that was a good way to approach it. The problem is, didn't leave you time to actually do the points, okay? But it's a good strategy. And what I would recommend to everybody is that you, and as I said last night, you gotta practice this. You're not gonna do this in 6 minutes unless you've run these 10 or 20 times without reference to anything else. You're not gonna be able to come in here with a blank sheet of paper and do this in 6 minutes. Okay? And I don't like to compare classes, but I don't know what's different between fall and spring. Yeah, I do. We've had all the disruptions, but that's no excuse. Okay, everybody but one in a bigger class was able to do this within the second, but by the end of the second week of class, or actually the third week of class with all the disruptions. I'm not sure how to count that. So I'm not trying to compare you with them. I'm just telling you, this is achievable. Okay. And you have to achieve it. You won't have the basis for understanding the rest of the course as well if you don't. You might take your way through it if your algebra is pretty good. But we did an assessment test on the algebra, and as a class as a whole, some people have pretty good algebra, but the class as a whole does not have strong algebra skills. Okay. One reason we're doing the pictures before we do the algebra is to give us a chance to develop the algebra skills. And that's what we need to be doing today instead of going back over something you've had 3 weeks to master. Okay. So you have to practice. I don't think people who miss class are viewing the videos, or they're not just viewing, you're supposed to engage yourself. If you're not in class, spend the time you would have spent in class with that video and do everything it asks you to do before I tell you what, you have to ask the class to do something and so forth. And we need to be doing that. And if we do, I've seen plenty of aptitude here. Algebra skills are a little shaky. So we can, but I think the aptitude I've seen, we're going to be able to fix that. All right. But we need to spend the time. As I said, this is the hardest class you're likely to have this semester. The hardest classes you'll have here, partly because your prerequisite courses didn't quite do what they aimed to do. Some of that has to do with COVID. But this course is what it is. So you have to work extra hard, meaning you have to do the homework. Nobody has the homework that was assigned in their notebook. You have to have a dedicated notebook. You have to be doing that homework. And everything builds. One day builds in the next, on the previous day, okay? And if you're not building it one day at a time, then we started making dots out here, halfway, 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 halfway. And we then expanded that into different ways of dividing up a square or a rectangle. And then we had simple rules. 1 over 2 down, 1 over 2 down, 1 over 2 down. You're at the red dot, now make it symmetric. It's your squaring function. And nobody did the squaring function yet. And then most people didn't quite line it off, right? Everybody kind of got the vertical, didn't get the horizontal. So there's all that stuff going on, and our habits have to change. We have to stay on top of the homework. You have to know where to find it. It's on the assignments page. Read it, do what it says. Okay, so now the quiz. And I'm just stating reality. People in this class are going to have to get more conscientious. Okay. So I'm just going to draw some things up there, you should recognize them. And just show you that it's feasible. Here we go. Oops, gotta divide it this way. Over one, down two, over one, down two. Over one, down two. Over one, well, then symmetrics over here, and here, and here. There are points. Sketch a smooth curve through the points. Here's one of our functions. You should be able to do every bit as fast as I did. That took 45 seconds or less, even though I was talking. Okay? No, I'm not asking you to do it in 45 seconds. I'm just asking you to do it in 2 minutes. Now, I mean, like the next class, okay? Oh, wait a minute. Okay. Okay, there they are. Now, I'm not going to take class time and video time to redo what I did last week. You're going to have to look back at those videos if you weren't here and see how to do the other 2 functions. Okay? And yeah, that's a scoring function, that's exponential, that's reciprocal, that's that curve got mixed up. For a 2-minute drill, if your curve was no better than those, it would be okay. If your curve was no worse than those, it would be fine. Okay. And then what do? We do things like, we put them inside a rectangle. We put a line up here, a line down here, we make estimates. That's pretty easy to do. I know it's pretty easy to do because people did it in class and they did it well. Okay. So we have to be able to do that. And then we have to be able to do a lot more with it. All right. So practice, practice, practice. If you haven't spent a couple hours practicing these, well, maybe because you don't need a couple hours, but whatever you've done, it wasn't quite enough. Okay. You didn't practice at all. You didn't practice at all. That was a pretty good effort. But these have to be right. You have to get in the habit of doing things as absolutely correctly as you can. And there's no reason you can't practice these and get them absolutely correct in the time you'd normally spend on any assignment. Okay, so do it. And the other 2 as well. Everything's based on these. Okay, so now we're going to sketch the scoring graph. Make yourself a good sketch of the scoring graph. You see how it's divided up? You know the rule. You should know the rule. Make yourself a good sketch. Okay. Pretty good rectangle. I'll get over here. It's a little not as vertical as it looked like when I was drawing it. But here's your rectangle that we're going to subdivide to make the scoring graph. Now, people are having a lot of trouble labeling the lines that we used to construct. Okay, I didn't notice that in class last week or So for some reason, either I wasn't noticing or, okay, so anyhow. They're possible that just wasn't noticing something. Okay, so we start with the center lines. Okay, what's the equation of this line here? Okay. X is between -2 and 2, right? And this is halfway. What's halfway between -2 and 2? Show me with your fingers or your face or whatever. It's 0. Okay. So X equals 0. Now, we draw a line halfway from here to here. I'm a little too close for them. Okay, just want to do a little bit. Okay. What's this? Show me with your fingers. What's the equation of this? Is it X or is it Y? Is it an X equals or a Y equals? There's an X. There's a Y. Okay. It's an X because X is the same everywhere in this line. We did this in class. We said, okay, draw me a coordinate axis, draw me 3 points with X coordinate 2. Now draw the line. I'm afraid people didn't focus on that. Okay, even though they were able to do it in class, I'm afraid they didn't follow up on it and have forgotten it. And can't tell me that that's an X equals something line, although I think most people can. Okay, and if you can't, start approaching this course differently. Follow up on what we do, review what we do, make yourself notes, review your notes. Okay, so we've got X equals 1 here, because it's halfway between 0 and 2. Okay, well, now we do another line because we're subdividing. We're edge subdividing from here toward the center. So we subdivide, we divide it in half, and now we divide in half again. And this is X equals 1/2. Because it's halfway between 0 and 1. Then we do these lines. And don't memorize that this is X equals 1 and this is X equals 1/2. You ask yourself what's halfway between 0 and 2. Because when I give you other coordinates, as we've already done on several problems, several examples, you're going to have to figure it out. And again, I noticed people doing a good job of figuring that out. So I'm not sure why it's more difficult here. Okay. But apparently it is, so we're going to deal with it. Okay, X equals -1 here. And X equals -1/2 on this one. So now we've got all our vertical lines labeled. And this is all we need. Okay. And you have to know, this subdivision, you subdivide twice toward the middle and you end up with 5 lines inside the rectangle, 5 vertical lines. Now in the horizontal direction, you subdivide from the top edge toward the bottom edge. So you go halfway, well, we're already halfway. So what is this? Y equals what? What's the value of Y everywhere in this line? It's 2. Why? Because it's halfway between here and here, and this is 4 and this is 0. Halfway between 0 and 4 is 2. Halfway between 4 and 0 is 2. Okay? So this is a line Y equals 2. This is Y equals 1 because it's halfway between 0 and 1. This is Y equals 1/2, halfway between 0 and 1. Did I say? I might have said this wrong. I said this one is Y equals 1 because it's halfway between 0 and 2. Might have said between 0 and 1. Anyhow, this line's halfway between Y equals 0 and 1. It's Y equals 1/2. Do another line. This is a line y equals 1/4, because 1/4 is halfway between 0 and a half. Then halfway between 0 and a fourth. Now, this is a line we don't actually use except for counting, but to do the rule, you have to do this as 1/8. Now, when we follow the rule says, and if you don't know what the rule is and don't have it written down and haven't been following it, you haven't been doing what you need to do. Start doing what you need to do. It's not difficult. You start in the upper left-hand corner, move over one line, down two lines. Move over one line, down two lines. Move over one line, down two lines. And then do it symmetrically on the other half, or if you prefer, over one, up two, over one, up two, over one, up two. There's your squaring graph. And it doesn't matter for the general squaring graph, for the shape of the squaring graph, what the boundaries are. You can do it in any rectangle, anywhere, any plane, with any boundaries. And we've been doing that for a week and a half. Okay. Now we want to make a table. What are the coordinates at this point? What's the x coordinate? What's the y coordinate? This means what's the x line it's on and what y line is it on? All the lines are labeled. We can just read them off. So can you fill out the table? Use it going from left to right as you go down the table. Okay, so if we're focused on this point is on the line where y equals 4. This is the leftmost point. It's the one we start with, right? So we can put in -4. It's on the line where x equals -2. So we can write in -2. And it's not -4, it's 4. Obviously 4, not -4. I don't know how to read, got overlooked. Okay. I swear I used to know this. Okay, now. We go over 1 and down 2. That's the rule for the squaring function. Make sure you know what the rules are. They're simple. And you would know what the rules are if you've been practicing. Okay. So where are we at this point? Well, vertical line's x equals -1, so we're going to put in -1 for x. And the horizontal line is y equals 1. There it is. What about this point? The vertical line is x equals -1/2. And the horizontal line is y equals 1/4. Next point we marked is the red dot. Don't have the red dot on here, but that's probably would be a good idea to always include it. Which I've been so far. Okay. So this point is on the line where y equals 0 and on the line where x equals 0. So that's at 0 and 0. Well, then we have 1/2, 1/4, 1, 1, and 2, 4. That completes our table. Now the question is, how would we calculate these values? Okay, now we follow a little reasoning here. I asked, what's a single arithmetic operation you do to 2 in order to get 4? Nobody wanted to say anything. But I even see the bottom of the screen here. Yeah, okay. What arithmetic operation I could do is add two. 2 and 2 gives me 4, right? Okay, what's another arithmetic operation I can do? Now, if you're watching, engage, turn the sound off, pause the video and figure it out yourself. What's another arithmetic operation I could do? And well, hopefully you've paused and done that. I could multiply by 2. 2 times 2 is 4. 2 plus 2 is 4. 2 times 2 is 4. Right? Now, what other arithmetic operation? Well, you got to kind of, let's just think if either of those really works for the other numbers. Okay, we said we could add 2 to 2 to get 4, right? But if we add 2 to 1, do we get 1? That's how. That operation, adding 2, won't work to give us these numbers. Okay. And doubling, multiplying by 2. If we multiply 1 by 2, do we get 1? No, we get 2. So doubling is going on. Is there a power then we could raise? We could raise 2 to some power to get 4. And somebody said, well, raise it to the second power, you square it. Which is coincidental is the fact that this is called the squaring function. This is a squaring graph. Tells you what to do. Okay. So each one of these numbers is the square of these numbers. Okay. So let's just do this. Let's do X, Y. Same X values. And 2y equals X squared. Well, if you square 2, that's 2 squared. 2 times 2 is 4. One squared is 1 times 1, which is 1. One half times 1/2 is 1/4. You multiply fractions by multiplying the numerators and multiplying the denominators. Well, the rest is very straightforward. So by calculating the squares of all these numbers, we see this number agrees with this number, this number agrees with this number, this number agrees with this number. Everything agrees. 0 agrees with 0, 1/4 agrees with 1/4, 1 agrees with 1, and 4 agrees with 4. So that now we can say the squaring function we can now say that this is a graph of I'll say the constructed graph agrees with y equals f of x equals x squared. At least at the points we plotted, and if we drew a smooth curve, all our other points should be really close, so that we do the estimates that we've been doing for a couple of weeks, they'll agree with the squaring function. Now, we've done a lot of that. If you haven't engaged in all the videos or attended all the classes, you need to go back and do that. You simply are not going to have a very good foundation for the rest of the course if you don't do this and or don't have really good algebra skills. Okay. And since most people don't have really good algebra skills, and it's easier to develop this and develop good algebra skills, this is what we start with. And this is easy to develop if you do step by step what you've been asked to do. Okay. Now, we can do other graphs, but we're going to say one more thing. Y equals f of x equals x squared is the basic toolkit squaring function. You construct its graph in the 4x4 rectangle with the red dot at the origin. That means that these lines here are x equals -2, x equals 2, y equals 0, and y equals 4. If you follow the instruction, the complete instruction for the squaring graph. I'll state it again, even though nobody's going to remember it. You subdivide vertically toward the center twice on each side, giving you 5 vertical lines there. Then you can reason out where those vertical lines are. That's easy. Okay, although you have to spend a little time talking about it. Then you subdivide from the top edge toward the bottom edge until you've got 5 lines. Okay, 1, 2, 3, 4, 5 lines. And you figure out what those coordinates are. If you start at the upper left, 1 right, 2 down, 1 right, 2 down, 1 right, 2 down, and then 1 right, 2 up, 1 right, 2 up, 1 right, 2 up, which makes the whole thing symmetric about the center. You have, to the extent that you've sketched it carefully and accurately, a good graph of toolkit squaring function y equals x squared between x equals -2 and x equals 2. If you draw this in the rectangle someplace else, you can always draw the squaring shape. You just, whatever rectangle you have, you subdivide it the way we subdivided this one, and you use upper left hand, right down to right down to, okay? Same rule. And then you get a graph of a transformed squaring function. And we've looked at the pattern a week ago. We looked at the pattern of how you get the formulas for these functions. Well, you have to know that. I can't go over that again. We don't have time in class. You got to pull it out of the video if you weren't here. And if you were here, you probably remember, but you probably remember it's probably fuzzy, you're gonna have to review it. If you didn't do the assignment last weekend, you know, that was leading into the assignment I put on the assignments page last weekend, using your version number and so forth. Okay, you got to do that assignment. Now, more briefly, you can do the same thing to the exponential function. Okay. And when you do, these coordinates are pretty easy. I mean, the x coordinates are -2 here, 0 here, 2 here, which means you got -1 here and 1 here, right? Then you start at the lowest line. I drew one too many lines down here. So I got a little carried away there. See, I would have made a 0 on that, maybe one extra line. I might not have given myself a 0 if I'd have known to start on this one. It says you draw 1, 2, 3, 4 lines, subdividing each time. And you start at the left edge on the first line. Not the lower edge of the rectangle, on the first line. The lowest line. And then you move over one, up one, over one, up one, over one, up one, over one, up one. And there's your exponential function, and that agrees. With y equals 2 to the x. Now you have to know about negative exponents. I have to assume that you do, although I'm pretty sure you don't. So you probably ought to review what I did last hour on the video, the MDE 61 video. I'm going to tell you all this in the assignments page if you read it. Okay? I'll tell you exactly what to do and exactly what schedule we're going to need to do it on. I'm going to move everything back a week. All the open math assignments. We can't start them until we've got this. But you still got to do them all, so you're going to have to do them in a shorter time. Now, I did schedule them in a short time, so we'd be done about a week or two early in the semester, so we could spend time reviewing. We're going to lose a week of review. But it's worth it if we get this down. It's unfortunate we got to do that, but people have to get in the habit of doing what they have to do. Okay, so this agrees with y equals 2 to the x, and you've got a table, and you can write the coordinates. It's -2, 1/4. -1 is at 1/2. 0 is at 1. 1 is at 2, and 2 is at 4. Because the x coordinates are 1, 0, -2, -1, 0, 1, 2. The y coordinates are 1/4, 1/2, 1, 2, and 4. Okay. Well, there's a lot more to it. That's it. And then on this, this agrees. With y equals 1 over x. And you can do a table. X equals -2. What's this line? This line is y equals -1/2. Remember, the rule is you start on the left edge at the point just below the center. And you move over one, down one, over one, down one. It's a very simple rule. Again, if you do this 20 times, and you don't have to do it 20 times, you can do it in 6 minutes, but doing it fewer times, then you'll remember what the rule is, you'll know you got it right. And you'll understand things about this graph that people don't normally understand when they take pre-calculus. It gets in their way later when they take calculus courses. Okay, anyhow, you got that. And then you start one line to the right at the top edge and go over one, down one, over one, down one. And that's it. And you don't connect anything on the left with anything on the right. And we got that on the second day of class. Pretty much everybody was here. So again, if you didn't follow up, start following up. Put aside the time, even if you've got to drop another course. Because not making it through this course will set you way further behind than any other course you take. No, talk to your advisor about that. They might say differently. Depends on your curriculum and your goals, okay? There we go. Those 3 functions, and the other 2 were covered last week. I'll even state what the rules are. I don't have time to draw it. There are other things we need to do. For the reciprocal square function, you line it off the same as the squaring function. You start at the first line Actually, not quite exactly, it's in the scoring function. You only do 4 lines going down this way, but you start then at the first line, over one, up one, over one, up. Sorry, wrong. Start at the upper left hand. No. Start at the line. Over one, up two, over one, up two, and you're already at the top edge and you're done. Okay. From the other side, start at the line just to the right on the upper edge, over one, down two, over one, down two. And you get your reciprocal split function. Okay. Then you have the cubing function. I'm not going to talk about that one right now. You'll have to look at that one because it takes on. It's a little different. You draw it in a much bigger rectangle. And they agree with simple formulas. I've got 3 minutes, and I'm going to talk for 3 minutes. A little bit about if I've got something to write on. Let's say this is a line y equals negative 1.4. What's the x coordinate? Well, if we draw a vertical line to the point where the y equals negative 1.4 line meets the graph, you get an x value somewhere between -1 and -1/2. So I'm going to say x is about -0.8. Now, this curve intersects y equals -1.4 when 1 over x equals -1.4. We want to solve this equation for x. How do we solve this equation for x? We multiply both sides by x. Multiply x times 1 over x equals x times -1.4. Now, I'm multiplying a fraction, so I'm going to, instead of just writing x, I'll make it x over 1. So when I multiply this out, my numerators multiply out to x and my denominators multiply out to x. And I'm going to write this as -1.4x over here. What's x divided by x? Can you show me with your fingers? 1. Any number divided by itself is 1. Well, I'm going to just put this in more familiar form. I'll switch sides. Say 1.4x equals 1. And then I'm going to divide both sides by -1.4. Now the 1.4 divides the 1.4 leaves you x. The one significant figure, that's 0.7. Okay. Not at all. Now I asked negative 0.7 because I'm dividing by negative. And I estimated -0.8. Was my estimate any good? Yeah, it was a good estimate. Wasn't great, wasn't perfect, but you know, it's a hand sketch graph and I wasn't even trying to sketch it accurately. Okay. So what I'm saying is you hand sketch your graphs, you do all the stuff we've been doing, and then you apply a little bit of algebra. Showed you last time how to do the algebra for a squaring function in a rectangle bounded by something besides these lines, okay? So. Last words. Do the work. Do what I asked you to do. Because nobody came in here able to draw these photographs in 2 minutes. Only one person even got one of them, right? Okay. You have to practice in order to do this. Okay, have I said that before? No. You have to practice to learn math. You have to practice to succeed in this challenging course. Okay? You have to spend a lot of time at it, and you have to do it in an organized fashion. Some people weren't here today, but did really well when they're in class. I'm not sure how well they would have done on this quiz. Because you knew this 30-point quiz was coming today, and 2/3 of the class isn't here. At least 2 people have emailed me and they have valid medical related excuses. So, and I believe they'll all be back next week. Nothing too serious. Okay.